Hello everyone. In this video, we're going to be solving a very exponential, a very logarithmic equation. Why do I call it that? Because we have log x at the base and ln x at the exponent. And it's equal to x. So we have log x to the power ln x equals x. Now, what is log x? Log x is base 10. That's how I use it at least. And ln is the natural log, which is base e. Okay, let's just make that clear first. And I'll be presenting, wait, I forgot to say, we're going to be solving for x values. Can you solve for anything else? Probably not. So, and I'll be presenting at least two methods. I'm thinking about at least two at this point. Now let's start with the first one. So we have log x to the power ln x equals x. I'm also going to show you a graph at the end if I don't forget. So to solve this problem, I'd like to do a couple different things. First of which is substitution. So why don't we go ahead and call L log x something. I could also call ln x something, but I want to start at the base. Let's go ahead and set log x equal to something. How about u? So log x would be u, and since the base is 10, this means x is equal to 10 to the power u. So now we're going to go ahead and replace x with 10 to the power u everywhere and see where that takes us. And of course, what is ln x going to be? It's just going to be ln 10 to the power u, and that would be u ln 10. By using properties of logarithms, we can bring the u down, okay? Which is an exponent. So that's ln x, that's x. Let's go ahead and plug those in. And of course, this one too. So log x will be replaced with u, ln x will be replaced with u ln 10, and x would be replaced with 10 to the power u. Great. How do we solve this problem? That's a good question, right? It still looks difficult, doesn't it? But we can take advantage of one thing, which is the presence of u in both of these exponents. In other words, I can write this as u to the power ln 10 to the power u, and this one is 10 to the power u. Now we can go ahead and replace both sides, not replace both sides, it's raise both sides, that's what I meant, to the power 1 over u. So if you do that here, to the power 1 over u, and to the power 1 over u, u and 1 over u are going to cancel out, and that's going to leave us with u to the power ln 10 equals 10. Well, this is kind of nice because we can just raise both sides to the power 1 over ln 10, and that should give us the answer, right? So let's leave some space here and write it like this maybe. And then we're going to go ahead and raise both sides to the power 1 over ln 10, and this would be 1 over ln 10, and these two are going to cancel out, and we're going to end up with u. By u, need to be, not this u, but it's u, need to be careful because we're not looking for u. We're looking for someone else, right? We're looking for x. And what is the relationship? Log x is equal to u. Or how do you find x from u? 10 to the power u. So x is 10 to the power u, but u is 10 to the power 1 over ln n. So x should be from here 10 to the power 1 over ln 10. Okay? It's like a superpower property, whatever. So that should be the answer, and obviously there's definitely more than one way to write the answer depending on how you use substitution. Okay, I can show you what would happen if you set ln x equal to u or t or something else, and then we can go from there. Pretty much the same thing, but just expressed a little differently. Okay, you could also do this, but we're probably going to do this for the second method. So let's go ahead and see a different way of substituting. What about setting ln x equal to something? How about t? If ln x is equal to t, then x would be e to the power t, and log x would be log e to the power t, which is t log e. Log e is a constant, so it's kind of like something times t. So now we're going to go ahead and substitute all of that, this one, and this one. T log e to the power t equals x, which is ln oops, nope, e to the power t, yeah. Okay, now notice that we have the t's again, so kind of like cancel out, and you end up with t log e equals e, and from here, t would be e over log e. Interesting. So would that be the t value? Yes, but t is equal to ln x, so we kind of have to do e to the power both sides. So ln x is e over log e, but x is e to the ln x, which is e to the e over log e. But wait a minute, all of these solutions are ignoring one fact, that t can be 0, because if t is not 0, we can't raise both sides to the power 1 over 0, right? So we have to be careful. Let me go back here. T log e to the power t equals e to the power t. At this point, think about it. If t is 0, then we're going to have t equals 0, which is 0 to the 0 equals e to the 0. Now, e to the power 0 is 1. 0 to the power 0 is also 1. So t equals 0 should be a solution, right? I know some people are going to be saying, oh, 0 to the power 0 isn't 1. If you take the limit, wait a minute, we're not taking limits here. 0 to the power 0 is 1. You know why? I made a video, you can go ahead and check it out. But in the meantime, take a look at the graph of y equals x to the power x. At 0, y is equal to 1. Because 0 to the power 0 is equal to 1. If you're not convinced, go ahead and check out my video. I'm going to share it right here. Okay? Anyway, so looks like we got two solutions. One of them being x equals 0. No, t equals 0. But t equals 0 implies that, well, what is t? T is ln x. So ln x is 0, which means x is equal to 1. Wait a minute, is 1 a solution to that equation? If you think about it, it'll make more sense. Log x to the power ln x equals x. If x is 1, this is 0, and 0 to the power 0 is 1. You see? That comes up one more time. All right, let's go ahead and take a look at the second method real quick, because that needs to be real quick, okay? Now, we have log x to the power ln x equals x. Now, at this point, you can do a couple different things. Log both sides, or you can ln both sides. Which one is better? I don't know. Let's just go ahead and use ln, because ln is, what's that called? I was going to say common, but it's the natural log. Bring this to the front, ln x times ln log x equals ln x. Nice. Bring this over here, ln x times ln log x minus 1 equals 0. Now from here, if ln x is 0, you probably know that x is equal to 1, which we already talked about. And from here, if ln log x is equal to 1, that means log x is equal to e to the power 1, which is e, and that means x is equal to 10 to the power e. Wait a minute, is 10 to the power e the same as this one? Probably, because I can change, use change of base, a couple different methods, and at this point, probably going to give me the same answer. But let's go ahead and take a look at the graph of this to get a better idea about the intersection point. Ta-da! As you can see, they intersect at x equals 1. What about the other intersection point? Where does that exist? Does that not exist? That's for you to find out. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.